calculus, and today we will do tangent lines, right? In the previous two lessons, we have done average gradients and first principles. In the second lesson, we have done differentiation rules. Now it's kind of like application. Now, what is a tangent line? Suppose we have a curve, right? Suppose we have a curve, any curve, right? It can be any curve, a curve as in a function, right? Let's just take a quadratic function, all right? And I'm drawing a tangent point here, right? Right. Now, see this point of here, at the point, this point of here is called a point of contact. Now, what's a tangent line? This is a tangent line. Let's call the tangent line g of x, right? Tangent line is always in the form mx plus c, right? It has, because it's a line, tangent line. It has to be, the equation of the tangent line has to be mx plus c. Now, this is a function f, the original function, f of x, right? Now, where they meet, the point here, that's called the point of contact. Point of contact. Now, question is, what's happening at the point of contact? First of all, let's see, at the point of contact, we know that, just say if this point is A, then the y value will be f of A. But at the point of contact, both the functions are equal. So at point of contact, we know f of x is equal to g of x. This is very important. At point of contact, f of x is equal to g of x, or f of a is equal to g of a, because both the equations are equal. Now, in grade 11, we have done something like this, but it's just that we did it with something called a discriminant. With a quadratic function, you can only do it with a quadratic function and line. So what we said at the point of contact, delta is equal to 0. What does delta equal to 0 means? We have equal roots. Okay, equal roots means when you solve this equal to 0, you're only going to get one x value. You're only going to get x equals basically a single value, right? You're not going to get x2 and x3. So, but if you're going to solve something like this, let me just draw a line. Let's just say you draw a line here. This is not a tangent line. See, if I shift this yellow part down, then that is a tangent line. Let me shift it back up. If you try to do, if you say, okay, if you say that the yellow line is g of x and this is f of x, you're not going to get a tangent. You can clearly see that yellow line is not a tangent to this function. So in this case, you will get two answers. So you're not going to get equal roots. You'll get delta greater than 0. So that's what we have done in grade 11. But now we are trying to use derivatives to solve this. Now, how do I go about finding the equation of a tangent line, right? So remember, there are many tangent lines on the function. So I'm just drawing this another tangent line here. There's infinite tangent lines at infinite different points. See, that's another tangent line. You can draw another one and so on. Anyways, let's focus our attention to this point of here, point of contact. So now I have a point of contact A and f of A. Now, how will I go and find the gradient of this line over here? Remember, the gradient of this tangent line. So remember, tangent, we need to find the equation of the tangent line. So we know g of x, we know the equation of the tangent line, let's call it y of t is equal to mx plus c. Great. How are we going to find m? How are we going to find m? The value of m. We're going to find m by using the concept of a derivative. Okay? Remember, to find the equation of the tangent line, it has to be at point of contact. Why? Because it's a point that lies on the line. So point of contact is A and f of A, right? I will substitute this inside this equation. But what is m? We need m. The value of m is actually f prime x, right? If you find f prime x, you're going to get some gradient function, okay? If you find f prime x, you will get a gradient function. But now, if you substitute the value of a inside f prime x, you are going to get a gradient. You are going to get something called an instantaneous gradient. So you'll get something called f prime a, which is equals to m, and it's the same m value there, right? So what is this giving us? Instantaneous gradient. And what is an instantaneous gradient? It's a gradient of the tangent line. Gradient or slope? Gradient of the tangent line. Right, so now easy, we can now use this formula. It's easier to first to use this formula. Y minus y1 equals m into x minus x1. Now, what is the point of contact? Point of contact is a and f of a. So this is the x1 value, and that's the y1 value. And what is m? F prime a. M is equal to f prime a. So now we can substitute all this and solve for y. Remember, we're finding the equation of the tangent line where we are solving for y. So y is equal to, sorry, y minus y1. What is y1? F of a. What's m? F prime a into x minus, what's x1? A. And that's your equation. You can just take f of a over and you have an answer. So you got y is equal to f prime a into x minus a plus f of a. And we don't really need to remember this equation. All you need to know is y equals mx plus c. At the point of contact, to find the gradient is f prime a. Are we good? So at the point of contact, we have two equations. What are the equations? We have f of x is equal to g of x, right? We have f of x is equal to g of x. And also, we have m equals f prime a, the m value from here. So now let's look at one question that I have. We have to do questions for understanding purposes. So I have about 6 questions. So, right, so I'm continuing my question series for calculus. So we stopped at question number, what is it? Question number 40. So now we are at question number 41. Now see, the graph is given, f of x is equal to x squared plus 1. And find the slope of the tangent line at x is equal to 1. Slope or gradient, same thing. What is the slope of the tangent line at x is equal to 1? Very simple. We need to find f prime x. Remember, to find the slope or gradient, we need the gradient function to the curve. And we want it at x is equal to 1. X is equal to 1 is right here. We want to know what is the slope at this point, 1. So first we're going to find f prime x. F prime x is equal to, find the derivative of this. Yes, Arnav, what's the derivative of this function here? There's so much of derivatives yesterday. What's the derivative of x squared plus 1? Differentiate this. Take the power, multiply by the constant, take away 1 from the power. So 2 times 1 is 2, x. And the derivative of 1 is 0, okay?
Oh, yeah.
Right, so that's what we are doing now, 2x. Now, what do we want to find? We want to find the slope or the gradient at 1. So I'm going to substitute 1 inside this function, gradient function. This is the gradient function. So if you put values in the gradient function, what do you get? You will get the gradient or the slope. So if I put f prime 1 inside, 2 times 1 is 2. So what's the gradient of the tangent line? What's the gradient of this line here? 2. Okay, hence find the equation of the tangent line. So first I want to find what is the point of contact here. Now, how do I get point of contact? I'm going to take the value of 1 and substitute inside this equation, right? Because the value of 1 lies on both the graphs. You're not going to substitute into g of x because this function is unknown, but this red function is known, which is the parabola. This here. So B, you're going to say point of contact, right? For point of contact, you're going to say x is equal to 1. And y is equal to x squared plus 1, right? So I'm going to substitute 1 inside here. So you're going to get 1 squared plus 1, which is 2. So we can clearly see the point of contact is 1 and 2. So do you know how to find the point of contact? You take the x value and substitute it into the known function. So now we have a point of contact, 1 and 2. Now we have point of contact and we have a gradient. So if you have the gradient and if you have a single point on a line, obviously you can find the equation now. So what's the equation? Y minus y1 equals m into x minus x1. So y minus, what's y1? 2. What's m? M is 2. The gradient is 2 into x minus, what's x1? 1. So if you open up this side, you're going to get 2x minus 2. If you take the minus 2 over and you add it to the other side, you'll get y is equal, or just cancel the minus 2 out and the minus 2 out. You'll just get y is equal to 2x. And this is the equation of the tangent line. Are we good? So we are using differentiation to find the equation of the tangent line. Are we good? Now, another question is, how else could we have done it using grade 11 knowledge? We have to say x squared plus 1 is equal to mx. You're going to have two unknowns there. F of x is equal to g of x. Now you need some other points here to find the value of m from here. You need some other information. Yeah, but we'll find some questions in functions from grade 11 and use calculus to solve it and try to use both methods. Anyways, that question is solved. Let's move on to the next question. Right, so question number 42. See what it says. All these questions are on tangent line. The graph of f of x, which is 3 minus x squared, has a tangent with a gradient of -3. So what are we dealing with here? We are dealing with two separate equations. So obviously we have a graph f of x, right? And we have something called g of x. So we know f of x is, let's write it in the side, a. Trying to solve a, all right? The graph of f of x, which is 3x minus x squared. So we know we have f of x, which is 3x minus x squared. And we have a tangent of -3. Now try to remember this graph. It is negative, so it's a sad face graph, right? And the gradient is -3, which means that the slope, the tangent line is somewhere around here, okay? Because of -3 gradient. Right, so this is the graph of f and that's the graph of g. So what is the graph of g so far? We know the gradient is -3, so we got -3x plus c. Okay, calculate the coordinates of the point of contact. How are we going to find the point of contact? Right, we know what the gradient is. What is the gradient? Gradient is -3. Okay. Now the question is, how did we get the gradient of -3? How did we get the gradient of -3? How? Right, so I gave you the formula before. To get the gradient of -3, you got to say f prime x, right? What is f prime x? F prime x is 3 minus 2 times 1 minus 2x. The derivative of 3x is 3. Remember, this is a linear function, so the derivative is 3 minus 2 times minus 1 is minus 2. Take away 1 from the powers. There's 3 minus 2x. F prime x, what is f prime x? The gradient function. So if you make the gradient function equal to the gradient, then you can solve for x. So great, that is fine. Now we have, take the 3 over, you get negative 2x is equal to negative 6. So x is equal to minus 6 divided by minus 2, which is 3. So if the x value is 3, what is the y value? To find the y value, you substitute into f of x function, the known function. So to find the y value, you're going to say f of 3, and my answer is 3 times 3, which is 9 minus 3 squared, which is basically 3 times 3 minus 3 squared, which is 0. Right? I substituted 3 inside the x value. So I have y value 0. So what's my point of contact? Point of contact is 3, 0. Okay. Calculate the coordinates of the point of contact. Could have, the question is, could we have done it in a different way? Can we do this question in a different way? Yes, we can. We can use grade 11 knowledge. Or, but it's better to use derivative. It's much more faster, right? I'm just pasting some stuff here. Or, see, look at the second method. Is quite interesting because it's going to test your understanding. What did we say? Remember, they want us to find the point of contact, but the problem is we don't know what the value of x is. We need the value of x to find the value of y, right? So we're going to say, okay, there's the point of contact here. This is the point of contact, which is some x value and some y value, right? Or some a value and some b value. You can label it anything. Let's call it x1 value, y1 value. That's a point of contact. Now, what's happening at the point of contact is that we're saying, okay, f of x is equal to g of x, right? And we only have a single solution. Point of contact, because it's a tangent line, we only have a single solution. So single solution means delta is equal to 0. So we're going to say f of x is equal to g of x, make delta equal to 0, find the value of c, and then solve. So this is a little bit more longer, but it makes sense. So 3x minus x squared, if you don't know calculus, that's what you will actually do. And g of x is minus 3x plus c. Bring everything over, you will get negative x squared. 3x plus 3x is 6x, right? And bring the c over, you get minus c is equal to 0. Refactorize everything, write it in standard form, x squared minus 6x plus c is equal to 0. So now we're going to say delta is equal to, okay, delta is equal to b squared minus 4ac, and that should give me 0. Remember, this is a 6. So we substituting into b, so that's negative 6 squared minus 4. What is a? 1. And c is just c, right? Is equal to 0. So you got negative 4c, and that is 6 squared is 36. 36 minus 4c is equal to 0. Take the 36 over. Negative 4c is equal to negative 36. This implies c is equal to 9. Now we have a value of c, which is 9. We can put it in here and solve. So what we have, this implies we got x squared minus 6x plus 9 is equal to 0. And solve this equation. So we're just going to have x minus 3 all squared is equal to 0. X minus 3 into x minus 3. So x is equal to 3. Since x is equal to 3, what's the y value? Substitute 3 into the original function, which is f of 3. And we will get 9 minus 9, which is 0. So what's the point of contact again? 3 and 0. Right, and that was the way to do it in grade 11, right? This long method here. Now, You can see calculus is much more faster. Determine the equation of the tangent, part B. Now, if you use your knowledge using discriminant and nature of roots, right? You can say the equation of the tangent is y equals, remember the value of c is 9, and what was the equation set up? Minus 3x plus c. So minus 3x plus 9, right? That's the equation of the tangent line. Or using calculus, we had point of contact, which is 3, 0, and we had m, which is negative 3. So we write down y minus y1 equals m into x minus x1. Y is equal to, sorry, y minus, what's y1? 0. And m is negative 3 into x minus 3. x1 is 3. So y is equal to negative 3x plus 9. So both cases, we ended up with the same answer. Okay. So when can you use nature of roots? Either to find the value of c or to find the value of m. But one of them has to be given, right? To use delta. You can't have two unknowns when you are using delta. You must only have a single unknown. Make sense? Abhinav, we good?
Yes.
Next question. Okay, so we have a question here which says the graph of f of x, which is x cubed minus 6x squared plus 4, has two tangents, okay? It has two tangents which is parallel to the line. Right, so what is the line? So this is some function, and this function has two tangents. Determine the equations of both these tangents. So watch here. I'm going to do a setup here. So we can say, okay, we have a function f of x, which is x cubed minus 6x squared plus 4. First, try to understand what the question is asking you for. So what are two tangents? So I'm going to say, okay, two tangents are tangent 1, right? So line 1, which is y equals mx plus c, or m1 plus c1, right? And line 2 is the second. Line 2 is y equals m2 plus c2. But now remember, we have a known equation. Both these tangents are parallel to this line. So what is this known line? We got 15x. We have a parallel line, okay? Parallel line is 15x minus y minus 1 is equal to 0. Solve for y here. So we're going to say y is equal to, take this negative y over 15x minus 1. 15x minus 1, yeah. So what's the gradient of this parallel line? The gradient of the parallel line is 15, correct? So m is equal to 15. Now, because these two tangents are parallel to both these lines, so m1 and m2 will be the same thing. So we can say y is equal to 15x plus c1, and y is equal to 15x plus c2. So line L1, L2 sorted, okay? We already know the gradients because it was parallel to the third line. Parallel lines have equal gradients, okay? This is the parallel gradient, and it must be the same here and there in line L1 and L2. But now the question is, does line L1 and L2 are also tangent lines? So how did we get 15? How did we get 15? Okay, that's the question. Now over here, you can't use delta because it's not a quadratic function, okay? You can only use calculus here. So how did we get 15? And how did we get 15? We said f prime x, the derivative is a gradient function. What is 15? The gradient. So make the gradient equal to the gradient function because it's a tangent to this curve. F prime x is equal to take 3 times 1, which is 3, x squared, okay? Minus 6 times 2 is minus 12x, right? Minus 12x, take away 1 from the power, and the derivative of 4 is 0, and that should be equals to 15. Now solve this equation. Solving this equation will give us 3x squared minus 12x minus 15 is equal to 0. We're solving a quadratic equation. Divide everything by 3, so you will get x squared minus 4x minus 5 is equal to 0. Right, so now this is the standard form. We can factor it out. X minus 5, x plus 1 is equal to 0. So x is equal to 5 or x is equal to negative 1. Now what is x equals 5 and x equals negative 1? X equals 5 and x equals negative 1 are the point of contact, okay, of the tangent lines. So we need to substitute the value of 5 and negative 1 in the original function. So we need to say, okay, y is equal to f of 5. What is f of 5? We're going to substitute 5 in the known function, which is the original function, the cubic function. So let's substitute f of 5 here. Please use a calculator and give me the answer. So if I substitute f of 5, that's 5 cubed minus 6 times 5 squared plus 4. I'm just going to do it on my calculator. 5 to the power 3 minus 6 times 5 squared plus 4. I'm getting negative 21, right? And when I substitute negative 1, please check that answer if it's correct. When I substitute negative 1, I'm getting negative 3. Right, so I've substituted. Yeah, thank you. So I have 2 point of contact. So point of contact is what? 5 and negative 21. Now, using this point of contact, I can get the equation of a tangent line because we already know the gradient is 15, all right? And m is equal to 15. So first tangent line. Or the second tangent line is point of contact we have is negative 1 and negative 3. And we have m is also equals to 15. So we can get the equation of the 2 tangents here. So say y minus y1. What is y1? Negative 21 is equal to m, which is 15, into x minus x1. X minus x1 is 5. So, by the way, we use the formula y minus y1 equals m into x minus x1. So y plus 21 equals, open this up, 15x minus 75. Y equals 15x minus 75 minus 21. Minus 75 minus 21. I'm getting minus 96. Okay? So that's the first equation of tangent line. Or the second equation of the tangent line, remember I'm using this formula y minus y1 equals m into x minus x1. Y minus what's y1? Negative 3. So negative 3 like this. M x minus x1 minus 1 like that. M is 15. So y plus 3 is equal to 15x, right? And 15 times 1 is plus 15, right? So now you got y equals 15x. 15 minus 3 is plus 12. So these are the 2 equations of the tangent lines that we are using for looking for, right? These are the 2 lines. Are we good? Now you can't use delta here. You have to solve it. So what did we do? Okay, so first we read the question. We said they want the equation of both these tangents. The tangent lines were parallel to this line. So we found the gradient of this line. We fitted it in. We said, okay, so The gradient is 15. How did we get the gradient? To get gradient is just f prime x. Okay, f prime x is the gradient. F prime x is a gradient function, so we can get the x value by equating it. You get the x value, 2x value, get the point of contact, we have the gradient, find the equation of the line. Right, so it's a little bit of analytical geometry involved in here. We're just using the analytical geometry formulas here. Let me just write it down. What we use, y minus y1 equals m into x minus x1. Okay, right, so nice question. Similar question to what we have just done. Just read the question carefully so you can understand it. So let's read this question carefully so we can understand. Well, determine the equation of the tangent to the graph. So the graph is g of x, 3 over x. Okay. Let me write it down. G of x is 3 over x, all right? That is perpendicular to the line. So we want to find the equation of the tangent that is perpendicular to this line. So let's say that's g of x, and this is my line, the tangent line. Let's call it LT, tangent line, which is y is equal to mx plus c. Now we know that there is a known line, and the equation of tangent is perpendicular to this known line. So this line is 3x minus y plus 5. What's a perpendicular line? The perpendicular line that we have here is 3x minus y plus 5 is equal to 0. So 3x plus 5 is equal to y. So now we know the gradient, which is 3. Okay? The gradient is 3. So the perpendicular, remember this is the gradient of this perpendicular line. So the gradient of the tangent, right? The gradient of the tangent will be the reciprocal, negative reciprocal of this will be 1 over 3. Because remember, the lines are perpendicular. When lines are perpendicular, okay, so this line is upward sloping. Then my tangent line will be downward sloping. My tangent line is like this, right? So this is my tangent line, and this is the known line. So the gradient of this line is 3. What's the gradient of the tangent line? Negative 1 over 3. What did we do? We flip the 3, it becomes 1/3, and take the opposite sign, because the product of both the gradients must be negative 1. Product of gradient of the known line and the tangent line must be negative 1 because of the perpendicular. They told us that it is perpendicular. Now, we can write down y equals negative 1 over 3x plus c. But now the question is, how did we get negative 1 over 3? Besides doing this thing here now. How do you get negative 1 over 3? Remember, what we are finding is that this is a tangent line. Right? Because this is a tangent line, the tangent line is here, y equals mx plus c. M is negative 1 over 3. To find negative 1 over 3, we have to say f prime x, right? But now in this case, the function is g, so call it g prime x, which is negative 1 over 3. I'm going to write g prime x as d dx of 3 over x. We have a problem because this is not in power form, so we're going to put it in power form. 3x to power negative 1. Now we are going to differentiate and drop the d dx. Negative 1 times 3 is negative 3, x to power negative 2. Take away 1 from the power, which is equals to negative 1 over 3. Now we're going to rewrite this in exponent form. You can drop the negative on both sides. See the negative here and the negative on both sides, you can drop that. So we got 3 over x squared is equal to 1 over 3. We can cross multiply. 1 times x squared is x squared, and 3 times 3 is 9. Okay, this implies x is equal to plus or minus 3. Okay, x is equal to plus 3 or negative 3. That's the x value. So now you have 2 point of contacts, right? So you're going to get 2 different c values. Determine the equation of the tangent to the graph that is perpendicular to this line. So If x is equal to -3, then y is equal to, you're going to substitute the -3 in here, 3 over -3 in the known function. Y is equal to g of -3, which is 3 over -3, which is -1. If x is equal to 3, then we have y is equal to g of 3, which is 3 over 3, which is equals to +1. So we have 2 point of contacts again. And so we have 2 point of contact here is -3 and -1, and point of contact over here is 3 and 1. So for the first one, point of contact, POC, which is -3 and -1, and a gradient of -1/3, we can find the equation. What's the equation? Y minus y1 equals m into x minus x1. So let's put this down over here and solve this. Right? Y minus y1 will be y minus y1, there's it here. So it'll be +1. M is -1 over 3 into x minus -3 is +3. So y is equal to -1 over 3x. -1 over 3 times 3 is -1, and take the 1 over, that's -1. So -1 over 3x minus 2. So that's the tangent line. For the point of contact, which is 1 and 3, and gradient, which is still -1/3, what happens there? We have y minus y1 equals m into x minus x1. Y minus 3 equals m. What's m? -1/3 into x minus 3. No, x minus 1, sorry. Should be x minus 1. Did I do this right? Y plus 1. No, no, no. The point of contact is 3 and 1, not 1 and 3. 3 and 1. And 1, so y minus 1 equals -1/3 into x minus 3. Okay, so we got y equals -1/3 x plus 1. Take this -1 over, you'll get +1. So y is equal to -1 over 3x plus 2. That's what we have. Right, so those are the two tangent equations with the same gradient. Because remember what they said, it must be perpendicular. Equation of the tangents should have set tangents. Anyways, if you try to analyze this graph, g of x is 3 over x, right? G of x is 3 over x. What does the graph of 3 over x look like? I just want to give you a visualization of what's happening here, right? Just trying to explain. Right, so 3 over x is a graph which is in the first quadrant, and there is a graph which is in the third quadrant, right? Which is a hyperbola function, 3 over x. Y equals 3 over x. Now we have tangent lines, right? So tangent lines, there is a tangent, which is, we want to check which one is a tangent, because the graph is in the first and third quadrant. Because the graph is in the first and third quadrant, we want to see which ones are tangent. -1 over 3x minus 2 and -1 over 3x plus 2. So are the tangents? -2 will be somewhere around here. Okay, that works. And you can clearly see the point of contact is -1 and -1/3. And there's another tangent line which is here. And those two lines should be parallel. So both of them are tangents. Yeah, so it does work. So that's 2, that's -2. The equation of this line. So there are two tangents that should be. I was just checking how many tangents. I'm confused whether both of them are answers. So they are both answers, right? So it's either this or this. So you're gonna have a tangent at this point of contact, and you're gonna have another tangent at this point of contact. And this line that they're talking about here, +5 is somewhere around here. +5 is somewhere around here, right? That line is upward sloping, which is perpendicular. Remember, +5 is going to shift, is going to go y-intercept 5. So this line is somewhere around here. Okay, which is basically perpendicular to both these tangents. And this was the known equation that we had. This equation was known. Anyways, that's a graphical representation of what's happening in this equation, in this problem. Last problem, right? Or two more. Question number 45, right? See what the question is asking for. Keywords, okay? Keywords, find the coordinates of the point with a line with gradient 7. Okay, so what we want, find the coordinates of the point with a line with gradient 7. So we know the gradient is 7, is tangent to the graph of this. So what's the coordinates of the point? The point that we are looking for is, remember, this is a quadratic function, right? And we know gradient 7 has to be upward sloping on this side. Gradient 7 is very steep gradient. So it's somewhere around here. So again, there's two ways to solve it because this is, let's set up both the equation first. So we're trying to find the coordinates of the point. In other words, the point of contact. That's what we want. We want point of contact. So if you're going to set up these two equations, we know f of x, which is equals to 4x squared minus 5x plus 2. And what's g of x? G of x is this line here. G of x is 7x because the gradient is 7x plus c. Okay, now you have two options. We can say f of x equals g of x, then delta equal to 0. Find the value of c, put it back into the quadratic function and solve. The other option is the derivatives method. So we want to know how did we get 7? To get 7 is f prime x equals 7. So what is f prime x? F prime x is 2 times 4 is 8x minus 5x plus 2. This is linear. So the slope of this is -5, right? And that must be equal to 7. Okay, so now we can say 8x is equal to 7 plus 5, which is 12. So x is now equal to 12 divided by 8, which is 3 over 2. You can divide by 4, which is 3 divided by 4, which is 2. So 3 over 2, 12 divided by 8. Now, if x value is 3 over 2, what's the y value? You're going to take this x value, put it into the original function. So to find the y value, you're going to say f 3 over 2. So if you're going to say f 3 over 2, you're going to say 4 times 3 over 2 squared. Put it into the calculator. Take 3 over 2 as 1.5. It's fine. 1,5, right? So 4 times 1.5 squared minus 5 times 1.5 plus 2. I'm getting 3.5, right? So when I substitute 1.5 into this equation, f 4 times 1.5 squared minus 5 times 1.5 plus 2. Yeah, I'm getting 3,5, right? So now I have a point of contact which is 1,5 and 3,5, right? Or you can say 3 over 2 and 7 over 2. Remember 3,5 is 7 over 2. Now, this was one method. Or, what's the other method? Or, let's see if delta works. Remember, delta only works with quadratic function and a tangent line. That's it. Because you're only going to have a single point of contact. So we know we can say f of x is equal to g of x. At the point of contact, both the equations are the same, and at the point of contact, delta is equal to 0. Delta equals 0 means 1x value, right? That's what it means. It means equal roots, 1x value. So now f of x is no derivatives here now without using derivatives. 4x squared minus 5x plus 2. And g of x is 7x plus c. Isn't that what g of x was? 7x plus c. Now solve this equal to 0, then make delta equal to 0, and then solve everything. So we're getting 4x squared minus 5x minus 7x is minus 12x, and 2 minus c is equal to 0. So now if you try to figure out what's a, b, c value, there's your a value, there's your b value here, and there's your c value here. So delta is equal to b squared minus 4ac is equal to 0. What's b squared? Minus 12 squared. Minus 4. What's a? 4. What is c? 2 minus c is equal to 0. Minus 12 squared is 144. Minus 16. Remember, this is minus 16 times this. So minus 16 into 2 minus c. Minus 16 times 2 is minus 32. Minus 16 times minus c is plus 16c is equal to 0. Remember, I multiplied those two. 4 times 4 is 16. So minus 16 times 2 is minus 32. Minus 16 times minus c is plus 16c. Now solve. We got 16c, which is equals to 144 minus 32. I'm just going to do it on the calculator. 144 minus 32. I got 112. I'm going to take 112 onto the other side. So I'll get negative 112. So the value of c is negative 112 divided by 16. Negative 112 divided by 16. I'm getting is negative 7. The value of c is negative 7. Now I'm going to take the value of c, which is negative 7, and put it into this quadratic equation here. So which is 4x squared minus 12x plus 2 minus 7 is equal to 0. And I'm going to solve for x here. So I have 4x squared minus 12x plus 9 is equal to 0. I think this is a perfect square. So you got 2x plus 3 all squared is equal to 0. Not plus 3, minus 3. So x is equal to 3 over 2. Now if x is equal to 3 over 2, what's y? Y is equal to f 3 over 2, and you will get 7 over 2. So what's the point of contact? We get the same answer, which is 3 over 2 and 7 over 2. I hope you guys understood that, right? And I hope you are understanding why we are using delta, because delta equal to 0 gives us a single x value. The tangent line and the function, quadratic function, they only meet at one point. If they meet at a single point, it means there's a single solution, right? And you can't use that in cubic equations. That's the reason why we use derivatives. See, this is any other equation you can't use. Only in quadratic equations you can use delta. Right, so all this is good. Next question. Let's look at question number 46. Arnav, you there? You making sense? Understood everything? I'm trying to do both methods, all right? Let's look at question number 46. A line with gradient 4. This is a nice question. A line with gradient 4 is a tangent. Very important. What are we underlining? Tangent. Because what is tangent? Derivatives. A line with gradient 4 is tangent of this. So there is a cubic function, okay? At the point 1 and 2. So the tangent line is together with the cubic function at the point 1 and 2. The point 1 and 2 is what? The point 1 and negative 2 is a point of contact. That is point of contact, right? Determine the values of A and B. So you can see we have two unknowns. So we need to set up two equations. First, how did we get 4? To get 4, we need to say f prime x. So let's write down what is f of x. let's call this function f of x, right? Which is ax cubed plus bx. And let's call this function g of x. G of x is what? 4x plus c. Right, we only want to find the values of a and b. Now, question is, how did we get 4? How do we get 4? To get 4, we need to find differentiate this. So we're going to say f prime x, which is equals to, what is f prime x? F prime x is a times 3, which is 3a x squared plus b. Why? Because this is linear, is 1 times b. 1 times b is b. Take away 1 from the power. 3 times a is 3a, so 3a x squared plus b. Now, that must be equals to 4, right? But how come we got an x squared over here? That's because to find 4, we're supposed to be substituting f prime 1. We know the point of contact already. The point of contact, POC, is the point of contact is already 1 and -2. We're not finding point of contact. Because the point of contact is 1 and -2, we know that the x value is 1. So we can replace this x value with 1. So we're going to say f prime 1 is now equals to 3a plus b, which is equals to 4. Right, so this is equation 1. Right, so we set up equation, we found the first equation by using the concept of derivative because of gradient function. Now the second equation we need to set up is, yes, how are we going to get the second equation? Second equation is f of x equals g of x, right? Okay. You can't substitute into f of x. Remember the point of contact. How did we get the -2 there? How did you get the -2 from the point of contact? So the second equation comes directly from the point of contact, okay? Second equation comes from using point of contact, POC. Point of contact is 1 and -2. Now, where did the -2 come from? -2 is the y value, which is on the graph of f of x, right? So what is f of x? F of 1 should give me -2. So we're going to substitute 1 inside this cubic function, not the derivative. Derivative is done. Now we're using the direct application. How did we get -2? Remember what I told you initially? Point of contact is a and f of a. So now we're saying f of a is -2. The value of a is 1. So f of 1 is equal to a times 1 cubed plus b times 1 is equal to -2. So what do we have here? A plus b is equal to -2. And this is equation 2. Now put equation 1 and 2 together and solve them. So let's take equation 2 and put it under here. See equation 1, bring down equation 1, which is 3a plus b, which is equals to 4. Now subtract both the equations, okay? Now if you subtract both the equation, b minus b cancels out, so a minus 3a is minus 2a. -2 minus 4 is -6. So a is equal to -6 divided by -2, which is 3. So the value of a is 3. So what's the value of b? The value of b will be, what's the value of b? A plus b equals -2. So the value of b will be, b is equal to -2 minus a. and A is 3. So the value of B is -5. Okay, so A is equal to 3, B is equal to -5, and that's my answer. And that will give us the cubic function. Because remember, now we are working backwards. So how do we create two equations? Always remember, whenever you are working with a tangent line, you have two important things. Number one, for tangent line, you have the gradient, right? Gradient is always f prime x is equal to m, right? And in this case, if you are given a value, then f prime a is equal to m. And the second important thing is the point of contact. Point of contact is a and f of a. So which implies we need to take the value of a and substitute it. So basically, f of a is equal to the y value. Y value. Okay, and that's it.